Hello everyone, this is Alex Designman. In this video we are going to do a routing that is going to simulate a main cabin harness for a vehicle. So the main cabin harness in a vehicle, it's the biggest harness inside a vehicle, and it's mainly routed inside the cabin of the vehicle, and that's between the carpet and the body in white. And every other harness inside the vehicle is going to connect to the main cabin harness. So there will be branches that go up towards the roof. There will be branches that through a grommet, they are going to go in the underbody. There are going to be branches that go inside the doors, in the seats. And also there are branches that go inside the engine compartment, and that connects with the engine harness, with the E-pass, front bumper, and depending on the type of vehicle, there might be other smaller harnesses. So this is a piece of body in white. It's a very simple piece. This is the tunnel. Usually inside the tunnel you have the gearbox and transmission. That's why you have this thing inside the vehicle between the seats. The seats are here in this area, and somewhere in this area or in this area you'll have the pedals, and somewhere in this area you'll have the gear shift stick. So this is a very simple body and white part. In reality, in vehicle there are a little more complex as a shape, so that doesn't really matter. What really matters here is that I'm actually showing what you really can encounter in those areas, what are the challenges, why is the harness routed as it is. We're going to see connectors, we're going to see grommet installation, plastic channels, retainers, connectors. We also have dynamic parts here between the seats and the cabin harness branch, because the seat will move back, forward, up, down. We also have here control units and electrical units. You can have like entertainment device under the seats, you can have audio amplifier, some kind of electrical control unit, even something like an engine control unit. It can be installed behind the dashboard here. We have the fuse box. So this is a project that I do in one of the courses I have on Udemy, Catia V5 Electrical Harness Design Automotive Projects. And inside the course we do all of this from scratch. Here I'm only going to do the routing very fast, because I'm going to use this slightly modified harness in one of the next video, where I'm going to show how drawings are made for the automotive industry and why, and what kind of softwares are used. In the course there are several videos where we do all this project from scratch. So first we put together the specification tree. I'll show you here how to make the structure with the products and the cut parts. The product that we are going to use for the harness, where we give electrical properties to the product, and then inside I'm going to show you exactly what you have to put inside and what should not be inside of this product. And in here we have a lot of, so let me just hide the mechanical parts, and what we have inside the harness product are various components, but we have connectors that before we put them here we study them, the connector with its counterpart, and we add electrical properties like bundle connection point, connector connection point, so that those connectors will automatically connect when you just click on one and then click on the other and it just connects. We also install the retainer that are used for connectors, and we do a study here to see how they work and how are they going to be mounted. And you see those connectors are very detailed. I'm going to show in the course how you download these connectors. Where do you find them? So they are free everywhere on suppliers, and I'll show you if you don't find it and you work in a company, you need to get in touch with the supplier. So I talk about this inside the courses. There is no drawing connectors, so you never have to draw the connectors when you work as a harness design engineer. The only way you will design a connector if the supplier tells you, look, I do not have a CAD model for that connector, it's old or whatever, we lost it, and you have a drawing left somewhere from the connector. Let's say you can use that drawing and you draw something that has less details. But let's say also if you do not have the drawing, you need to get that connector in hand. You need to measure it with a caliper or with a ruler. You need to measure it very well and then design the connector with less details. This is the only case where you do that. Otherwise, if there is a 3D model of that connector, you need to use that 3D model. That's mandatory in the automotive industry. And I talk about this more in the courses. And it's the same for the retainers. You see the details that we have here. Actually, everything you see here can be downloaded in the course. So it's not I'm just showing you their other websites if you want more. So if you want hundreds of connectors to play around with them, I show you where to find them. Also have plastic channels, so those are custom made, those are designed by me. So there is then grommet, other connectors, retainers. So all of those, they are electrified, and we are going to see immediately why. After we electrify everything, we just put everything in position. All the retainers, we put them in their holes, all the connectors in their positions, and we discuss in there how you choose that position, what you have to look after, what are the problems that can appear, and so on. So all the requirements for harness design. And then we start to design the wires, the bundles. So this is actually what we are going to do in this video. Here the structure is already created. We have the main cabin harness here, and we also have the multi-branchable file. So this is the cut part for that is going to contain the wires, the bundles. This is a cut part that has electrical properties and can take branchables, and it's inside a product with electrical properties. So I'll show you in the course how to do those. And then to start to design, we need to start in one point. And here we have two retainers on this sheet metal part. So we discuss about all type of retainers. Basically the retainers, they have two kind of properties. One of them is the one that connects onto the vehicle, and the other one is the one that connects onto the harness. And I explain in the course all type of retainers, why they are like that, why some of them they have a hole, oval hole, tape on stud, strap on, and so on. So this is a specific case where we use oval holes, and I explain in the course why we need to use the oval holes here. And by the way, the course, you can find those links everywhere on my YouTube channel. On each video you can have the Udemy link where you can find all my courses, or the LinkedIn where you can contact me. Please don't write here at the comments or try to email me or something, because I don't watch those communication channels. The only communication channel with me is on my LinkedIn account. So you don't need a premium LinkedIn account, you just need to connect. So to send me a connection request or a follow or something like that. And then the message button will appear, and you can send me a message. So from here, let's start with a bundle. I use this retainer on top for those connectors, and this retainer on the bottom for the connector here. And again, in case you're wondering, I explained in the course why we need two of them, and we cannot use just one. There is a small detail in there that changes everything. So if I activate the branchable here, you usually get the window for the branchable, and bend radius ratio is 2. By the way, I explained everything about bend radius ratio in the course, how it's calculated, and everything it exists, and everything you have to know. Root. So I click on this one and this connector here. Okay, so I think I'm just going to add random dimensions here in the course. We also do some calculations for the dimensions. Click OK. I need to add a branch point here, and here I need length, so I need a certain length around here. So there are specific lengths between the connectors, branch points, or retainers or branch points that are used in the automotive industry. And again, you see how easy I can go down the rabbit hole with those information. That's why I made a whole course about it, which is very organized, and you can find out everything step by step. So you just need to watch all the videos in order. Here I'm going to use 50 millimeters and do another branch point. 6 millimeters I'm going to do for this one for the diameter. Start from the branch point, tangency, and go to the next connector. The second retainer, it's for the branch that goes to the seat connector. This is a connector that's mounted under the seat on the seat frame. So I don't have the seat here because we don't really need that, but I have a specific project in the course where we deal only with the branch that goes from here to the seat connector, and I also have the seat here in all the positions, and I show you how to do that dynamic move, how to calculate that. And basically that's one of the most difficult piece of dynamic harness that you have to do inside the vehicle, because many times the space is really tight here, so I show you a lot of tricks in there. And this is the connector that will be attached to this bundle. And because all of those connectors, I show in the course how to add connector connection point to each one of them. You can just use the connect electrical devices command from Catia v5. Click on one, click on the second one, you can already see the connector connection point and it just connects. So in here I'm just going to add a branch. We are not going to do the calculation in this video because that can be a video on its own, because it takes quite some time to do all of this CAD work back and forward. You have to do it until it's perfect, otherwise it's not going to work in reality. So this is why we do all of this CAD work. This is why it's so important and it's so well paid. So it's very good to learn to be an electrical harness designer. Of course, the payment is going to be different everywhere around the world, but in UK, when I used to work as an electrical harness designer inside a company, as a contractor, I used to take between 40 and 45 pounds per hour. So usually between 42 and 45 hours per week. That's what they would require me to do to work. So that means 6,000 pounds per month. After taxes, around 5,000 pounds, something like that. Maybe 4,500 after I pay all the taxes, the accountant and all of that stuff. If you work on a permanent contract, you can get like 2,500 in hand. So you can get like 35,000, 40,000 pounds salary per year. So it's way less than working as a contractor, but it depends what you like. As a contractor, I had a 1 week notice period. As a permanent worker, you have 2 months. I prefer the contractor, because if you work 1 year like that, you can just make a lot of money, have them in the bank and just be relaxed after that, no matter what happened. And a lot of us, we seen what happened in the 2020, so that was pretty hard for a lot of people, remained without work. So I also was workless for a period of time, but it wasn't a problem. So back to this work now. Let's do this bundle. Let's do 8 connector, retainer. So there will be another retainer here between this connector and this retainer here. There will be another retainer here. Probably I'll add it later in the video. But in the course we add that, and I explain there why. That's a very important retainer. So this is a good start here. Now we just need I need the main bundle around here so I can connect everything to it. So I'm just going to add this main bundle. Let's do 15 to see how it looks. Just click on those retainers. So this is clashing right now with the body and white, but we will fix this. So from here, let's go add before here, and from here we go. I need the branching point on the main bundle here. Say I add it in this area. So here, this one add after, and so we do something similar in the course, but I explain more in details what you have to look after here, what the problem can be, what DFMA problems you can have with this one here, why you cannot add any retainers in this area, and so on. In here, I'm not going to go in those details, that's too much, but I'm just telling you those in case you're wondering why do we do it like that, or maybe you are more experienced and you can see that there are some problems around here, but I'm not going to go in those details right now. So now, because we fixed that, I can have a branching point somewhere in this area. I want to use this one and just do length. Let's do 50, that's okay. In fact, we just modify this to 30. That's better. Let's see now. Okay. Before. So this orientation, you see, I can orient this like that and like that. Those are kind of details that we go into the course. So I show what gives you this orientation. What is the factor in the harness that decides where do you take this? So you put it like this, or you go here and you just remove tangent. So you do it like this. So there are 3 ways, and this is an important fact. And also this those two branches now they can become one, so I don't need any more for them to be two of them. So we add a branchable point here, length, zoom in this area. Okay, so I need 50 here. In fact, no, 30 works, because this is the retainer will allow that. Add after this point, so we can have a tangency here, no problem. So this is not okay like that, it needs some slack, and we are going to add that at the end. So if this video it becomes too long, I'm going to do a part 2. So you can already see that it takes quite some time to do those harnesses. So now here, because those harnesses become one, this branch from here to here obviously is going to be thicker. So I need to deal with that. So I made that thicker, 10 millimeters. It's okay. And let's go forward. Now this is the main branch. Adapter here. So there is going to be a branch that is going to go here to the right hand side door connector. We're going to do that at the end. Until then, I'm just going to do this main branch. So this is the whole branch. So first of all, I want to deal with the slack in the main branch, because that's going to affect all those secondary branches. At before and as we also do in the course, so this harness will proceed forward to the back of the vehicle. We just don't have it here, so that's why I just end it here. But we're going to have a branch that goes up to the door connector that it's not there, but I will add it. So this is the right hand side passenger door connector. So I also show in the course a lot of names that are used for connectors and how do you identify the doors. You have a right hand drive, right hand side, left hand drive, left hand side, and so on. So you need to think for all the markets in the world. You have the right hand drive, left hand drive, and then you have the right hand side, left hand side for everything. So a big shock to harness design engineers when they go and work in the domain is when they see all of the versions that they need to do for the harness for various type of vehicles, and also for all the markets. You need to take the whole harness and just do it from scratch for a left-hand drive vehicle or for a right-hand drive vehicle, because all the components are going to be reversed. Components that you have here are going to be on this other side, and so on. All those sensors for the pedals and the gearbox and everything. Diesel and petrol, they are different harnesses. So in here, just going to add some slack. We're not going to look too much here on the slack, but that's for the course where we have more time. I do more analysis on how we add the slack and why and how much slack you should add. But in here I'm just going to add numbers just to make it a little more smooth. I'm going to show you a few things here. So this doesn't need slack. This is, you need to check manufacturing tolerance here. There are some things around here. So this one, we fix this with slack. So this needs to go on the body and white. You cannot have something like this here, because the carpet is going to follow the body and white. So you cannot have this, you know, this needs to go very deep, like very deep, 10 millimeters. Just needs to sit on the body and white. And depending on the thicker a piece of harness is, the more rigid is going to be. So that's important, because when you add a lot of slack, then you need to make sure that that's not too flexible, and if it's a smaller harness and it's going to vibrate on the body and white, because that's very bad when they do the testing for the vehicle and you hear like a rattle noise, a piece of harness rattling on the body and white inside the vehicle. That's very bad for quality department. So that's why if you're an experienced harness design engineer, you're going to get paid very well, because there are a lot of things that you need to look at. So just enough slack. We don't need to follow this piece of sheet metal, obviously. And in here, again, this is a long piece of harness from this retainer to this connector. So you need to be careful what do we have around here. You need to check on the 3D models that it doesn't vibrate onto something. Okay. So from here we decide where do we go into this connector here. So let's just route something. In fact, we need a branching point. Let's add it around here. Reference length. Choose a point here. Let's start with 60. Branchable. Here. Here. So the door harness is not that thick. So let's do this smaller. Let's try 10. I think it's 10. It's decent for a normal door. So this can be okay or not. I think in this area it should be okay. So you kind of have the dashboard in this area. But if this would have been lower, so it has to fit under the carpet, then maybe this is not okay. You need to stick this to the body and white wall. So this wire, maybe it would need another retainer in here. So this is just like an example of presumptions that we do and examples that we do in the course. That's how I show you things. So if you think logically, what kind of wires they go inside the door? So you might have commands from an electrical control unit, wires that go from here to this harness inside the door. But you also have wires from the audio amplifier that go inside the door. So you have wires from both directions injecting in this bundle here. So now those ones, they can just go here. Branchable from here to this connector. Let's make this a little more thicker, 12. Okay. Exit, and let's add some slack very quick around here. 5. So this one. So now this is kind of half of the harness in this area here. There is a small error here that I did. So basically the main bundle needs to go inside the plastic channel, not straight to those connectors. So I forgot about the plastic channel. I'm just doing this from what I remember in that I did in the course. So to do that, usually plastic channels are not electrified. You just need to put a point there and just connect the bundle to that point. Electrifications are usually used for retainers, connectors, because those are database objects. Plastic channels are pretty custom, so you don't need to electrify them. So this is how I usually go into part design. I put a sketch. So the sketch, it's inside the file of the branchable, because that's a cut part file. You can add anything from the part design workbench in it. So I'm just going to add a sketch on this surface. So the sketch, it's right here, and I'm going to add a circle on that sketch, which is going to have the diameter of the bundle, in this case is 15. And I just want to imagine how this is going to connect to the plastic channel. So in reality, this is not finished. So this is going to have some holes, and the cable strap is going to be inserted in these holes and is going to hold the wires onto the plastic channels. So in our case here, I'm just going to make sure that this is this circle is in the middle. And for now, I'm just going to add a distance from the bottom of the plastic channel, minimum 3 millimeters, let's say. And I do this because I just want to constrain this circle. I don't want to leave this unconstrained. So just exit the workbench. In fact, this point right here in the middle, I need to make this line of the circle can be a construction element. So I don't see it. We don't need to see that. We only need to see the point. And in here we have this one inline connector, this. So I'm going to replace this with this point. And also need tangency. Let's use this. Okay, so in this case here, we have here a branch point. So I'm going to take this a little more further away. Let's see, 100, maybe 120. Okay. So I'm going to connect this to the bigger connector. I'm going to make a branching point here. Length. Branch. From the branching point to the connector here. So this branch on the bigger connector, this now has two parts. So let's make this here 12. Okay. So this part here seems to me like has some extra slack that it's not needed. So let's try 3. Okay. So this slack, it's not very much needed in here. I'm just going to add 1. But there is more like needed here. So this has already 3 and this one has nothing. This one can have more than 3. Okay. Fine. So from here, we do not design bundles in plastic channels. If you're for a company and they tell you to design it, you know, you just do it. You don't have to say no. But if they give you to make that decision, I personally do not design bundles inside plastic channels because it's not needed. I just make measurements of the plastic channels and I make sure that all the wires, they fit inside the plastic channel. This is everything that matters. So next we are going to have a bundle that continues to go forward to the fuse box, and those connectors here, they go to the grommet to the other side. I explained in the course what a grommet is, why is it used, why is it needed. So this is the first half of the harness. Let me just save this because I've been working for quite some time now without saving anything, and usually that's not a good idea because this is how you lose a lot of work and you have to start over. So nobody's going to pay you for that just because you forgot to save. And because this video it's a little too long now, I'm going to make a part 2 and continue to route the harness on the other side. And that's going to be shorter because we go straight into routing. In this video I had to make some explanations at the beginning to understand what is going on here. So without any further ado, I hope you like this and see you in the next video.